Now, see, we are talking. Good morning to all of you. I'm Vishwara. I'm going to teach you our next topic. It is that Gauss law. And now, Gauss law. It is. We are discussing about the first of all flux. Afterward, the flux. We are talking about that the Gauss law. So, see now. First of all, what is the our Gauss law? So, hi. So, I am talking about the Gauss law. So, we are discussing about the Gauss law. See what will happen. So see now my first slide is that. So see this one, it is our. So here what will happen, there is a flux. It means what? Flux means outwards, something of outwards from any particular area. It is a flux. Suppose the water, it is outwards from pipe, a water pipe, it is a flux. Suppose we are talking about the any wind, it is coming from any the window, it is a flux of the water, flux of the air, flux of water, flux of current. So we are talking about the flux of charge. So electric flux. So we are talking about the electric flux means what? Electric flux here, electric flux, it means here we are talking about the electric, and the flux means we are passing of how much passing of electric, it means our electric flux is that. So see here what will happen, there is a our electric flux is that. So here in this phi it is equals to, we can written as phi is equals to what we can write, we can write the phi is equals to C, sorry to say, but phi is equals to here Ea cos theta. Okay, Ea cos theta. But now here this one, it is my Ea cos theta. So we are talking about the Ea is that. So here see, there is a area, it is my A area, it is A. Then what will happen here in A is that area is that Ea, phi is equals to Ea. So here E, it is my this E, it is equals to my electric field. And see this A, it is equals to, see this A it is our area. So we can written as E dot A, this one it is our E dot A. Now E dot A means what? E here it is a dot product. Those vectors, this is both as vector quantity, but we are talking about that the when vector quantity where product with the dot product, scalar product, it will be gives that this answer is in the form of resultant scalar product. So see phi is equals to what? Phi is equals to Ea cos theta. So we already discussed in this line our physical lectures. But now area A is the vector normal to the surface. So see here our A, it is a normal to the surface. So what will happen? See this one, it is our A it is normal to the surface. What will happen? It is normal to the surface, and also it is parallel to the our electric field. So magnitude of A and direction normal to the surface, but theta in the angle between. See here cos theta, this is written as cos theta. Now what is the cos theta? Cos theta means what? It is the angle between what? Angle between this our electric field and our what? Electric field, and also our area, electric field, and as well as our uh, electric field and our area. This one, it is our A. Theta means what? It is a between that the angle between our electric field E and our area A. So this is our theta. So we can see this one, it is our theta. It means what? It is a theta means what? It is the angle between our electric field. See, suppose it is my electric field, and suppose this one, it is my area. So how much angle they are making? It is theta. Okay, so we are going to our next slides. So see, you can think the flux through the sum of surface are measure of the number of field lines which pass through that the surface. It means yes, what will happen? See, flux depends on the strength of E. So means what? How much water flow are there? It is depends upon that how much force it have. So how much force it have? It means how much the force it have. It will be more passes, more number of water will be, molecules of water will be passed from that pipe. Why? Because it have a more force. So see the flux, it is here same as, but flux depends on the strength of E. So strength of E means what? See here what will be there. Here it is my electric field. So electric field here, it's on strength. So see it's on strength was that on surface area on the relative orientations of the field and surface. So see now, see this one, it is our area and surface. It have a, how much numbers are there, it is depends on that. So here the flux phi is equals to E dot A. And now see the again our next is that, so the flux also depends. First one, it is what? So flux, it is depends on our area and our electric field. Afterwards we are talking about that the, it is normal, it is how the related orient, how much electric fields or lines are there. And the third line, there is a depends on the flux also depends on orientation. So flux also depends on orientations, means what? There is an angle between both of the our electric field and area. So the number of field line through the lines through the tilt surface equals the number of through the projections is project is d projections is. So here, hence the flux through the tilt surface is simply given by the flux through the projections. So see, ea cos theta is that. So now what will be there here? Ea cos theta, they are given due to this phenomena because they are making as a theta with the angle of our electric field line and our area. So here it is a making angle. See, this one it is a, here this one it is my electric field line and this one it is our area. So here it is one of the angle making and this one it is my theta. So this one it is my angle is theta is that. So see here what will happen? This one it is my theta. So now we are discussing about this one, it is our angle of theta. Now we are talking about that the next slides. See what will happen that, now you have to do this homework. What is that? The calculate the flux, the electric field E through the surface A in each of the three cases shown. How the flux will be we are getting. So see, in the first situations it is what? Here it is a parallel with the electric field. Second, it is a perpendicular with the electric field. And third one, it is a making angle, particular angle with the our electric field. So you have to check it and you have to find out the how it is related, how it is give the flux, total flux phi. How can they give? So total flux we have to find out. You have to count the value of flux phi. Okay. So now see, this is your homework. Now, what is the surface is curve on the field varies with the positions. So see again, we divide the surface into small region. So see, now what will happen? It is we are talking about that the our see, this one it is our area, this one it is our area, okay, or random area we are divided. So we have to measure here in this area. We have to measure what? We have to measure, we have to measure the area. First of all, small area, we have to measure the flux, total flux phi. Okay, so total flux phi we have to measure. Then what we have to do? We have to change the our we have to change our how to orientation we are doing. So we have to first of all take the small discrete quantity, because we haven't any particular area or any particular electric field. Why? Because it is a random orientation. So random orientation have a random motion, random shape is that. So random shape haven't any kind of that what we can say, any kind of any particular unique constant value. So we have to divide into separate discrete quantity. So discrete quantity means what? See, so discrete quantity means what? Here we have to convert in this discrete quantity. So suppose here we are just this one it is our sorry to see, this one it is our line. Okay, so we have to separate in this portion, only this portion we are taking this much portion. So it is our dl. According to that same situation, we are taking as our any particular area. Okay, so here see, this one it is our shape and we are just taking as small of the area of that shape. So we can take this small area. See, this one it is my dA. Okay, dA. So dA is that. So what will happen? There is our dA is that. Then it means what? It is we are just considering as a small discrete quantity. Okay, so discrete quantity is that. Then so discrete quantity means what? So see here what will be there. There you are just considering as a small part. Okay, so see, this one it is our small part we are considering, and this one it is angle, making angle with the our electric field line. It is our what will happen? It will be our electric field line will be making an angle, so we can find out that the flux phi is equals to our d phi is equals to, because we are just taking as a small quantity, okay. So dA and our E, so electric field will be constant, but see our area will be small. So what we have to do, we have to take that the phi is equals to, we are EA dot EA, but we are whenever we are talking about the small area, so small area we use that, so we can written as here this one, it is our d phi by d phi. But we have, so see here we are talking about the d phi is equals to E into dA cos theta, okay. But see E into dA it is equals to, whenever suppose it is cos 0, value of theta it is 0, then we can written as E into dA, because cos 0, value of cos 0 it is equals to 1. So now to obtain the total flux we need, why, how, so first we divide it into what is the surfaces curve on the field vary with the positions. So first three step is that, first step is that divide in the surface into small region with the area, then after second the flux through the dA particular area, how much flux are there, and then after third thing you have to do, you obtain the total flux we need to integrate over the surface. So see this d phi we have to take as integrations, okay. D phi integrations is that, so d phi it is integration of d phi, it is equals to E into dA, so it will be gives us total flux phi, it will be gives us the value of flux, okay. So value of flux it will be gives us total flux. So now see here we are talking about that the C total flux phi, okay. So total flux phi is equals to d phi into d integrations of E into dA. But now in the case of closed surface, so see first of all you understand what is the flux, what is the whenever there is a three orientation is that, then what will happen. But now what we have to do, we have in the case of closed surface, so whenever we are talking about the closed surface means the loop means the interior over the closed surface. So suppose we are taking as a wall, okay, a wall is that it is our closed surface, so closed surface it is a totally closed, so we have to take about the total closed surface. So what will happen, there is our, so we are talking about the total closed surface, so what will happen, there is our total close, so see this one it is our see it is a closed surface area, okay. So closed surface area haven't any of the closed surface haven't any of the outside surface, so we are talking as closed surface. See this one phi is equals to, phi is equals to d phi integrations of closed surface d phi, but closed surface d phi is equals to what, see E into dA, okay, E into dA. But now E into dA is that, see here again what will be there, it is a closed surface integration, it have what will be the, for closed surface the flux is positive for field line and that leaves the enclosed volume, the flux is negative for the field line. So enter and the enclosed volume, if the charge is outside closed surface the net flux is 0. So what will happen, the net flux is our 0, why, because of that the flux is negative for field line, okay. Then that enter the enclosed volume, and if a charge is outside a closed surface the net flux is 0. So as many lines live in the surface as line enter in, so see what will happen, there is a positive electric flux in this region, and see the negative electric flux in this region. So what will happen, there is a both this are that, so what will happen, the resultant flux it is equals to 0, the resultant flux it will be 0. So see now for the which of this, so for the which of the suppose see there is a, for those closed surface A B C D is that, okay. So the flux of electric field produced by the charge is 2q is 0. Here see there is a 2q charge is that, it is a 0 or it have any of the value of any flux is that. So see what will happen, there is a, see the spherical surface is that, okay. You have to see this, you have to solve by yourself for which of this closed surface ABC, the flux of electric field produced by the charge 2q is 0 or not. So you have to solve it. This another question I have given to you. You have to solve by yourself. And now next question is that now we are talking about our next slides. Okay, so spherical surface with the point charge at the center. So see here, the flux of electric field. See here it is our suppose see this one our spherical bob is that. Okay, so spherical bob is that. So spherical surface with the pointer, see this is a positive charge inside of the our surface. So Gaussian surface is that. See why this surface, okay, this surface we can say it is our Gaussian surface. This surface is Gaussian surface. Why? Because it is a closed surface. Closed surface also known as our Gaussian surface. Closed surface it is known as a Gaussian surface. So see what will happen. This is our closed surface, and now here what we are doing here, we are just considering as a our small area dA. You can see this one, it is our dA area. Okay, and in this form our electric field, see this, it is going in this direction. Our electric field it is going in this direction. So it is our Gaussian surface, and this Gaussian surface, the for closed loop surface, flux phi is equals to phi into d phi is equals to what? E into dA. But see E into dA is equals to what? E dA cos theta. E into dA cos theta. But now according to that, again we are know about the value of C E electric field, E it is equals to what? KQ upon R square. But instead of value of K it is equals to what? K it is equals to 1 upon 4 pi epsilon 0 Q upon R square. So Q upon R square, it is our electric field. See this one, it is our electric field. Okay, but see now dA upon R square, dA upon R square, it is we can say, but it dA upon R square, it is we can say it is a solid angle, or d omega we can say. Okay, but see the value of d omega, it is equals to what? So total enclosed see d omega it is equals to, see we have value of only, we are getting that the value it is equals to 4 pi. Okay, so d sigma it is equals to what? Integration of d sigma d omega it is equals to closed surface integration of d omega it is equals to, we are talking about that the it is my see 4 pi value. So see here again, here 4 pi, this 4 pi and this 4 pi will be cancel out to each other. So we are getting that the value it is q upon epsilon 0. We are getting the value of q upon epsilon 0. So this q upon epsilon 0, so we can say whenever the Gaussian surface is that, or whenever Gauss law is that, whenever enclosed of the surface is that, or whenever closed loop surface over there, the flux phi is equals to what? Flux phi is equals to closed surface integration of E into dA, it is equals to q enclosed by epsilon 0. Now again here what is the epsilon 0? Epsilon 0 it is the permittivity. Epsilon 0 it is what? Permittivity. Okay, so now the Gauss law of the electric flux through any closed surface equals the enclosed charge upon epsilon 0. So see this one, it is our q upon E integrations, closed integrations of electric flux phi is equals to in closed integrations of E into dA, it is equals to what? Q upon epsilon 0. So q upon epsilon 0, it means what? Q upon epsilon 0. So this is always true. Essentially it is a provide the very easy way to find the electric field for highly symmetric cases. Okay, highly symmetric cases. So now our next slides is that, so calculate the flux. Again, the calculate the flux of electric field phi at each of the enclosed surface A, B, C, D, phi A, phi B, and phi B, phi C, and phi D. Okay, so you find out the value of our closed surface. Total for surface flux phi it is equals to what? Flux phi B it is equals to what? And flux phi C it is equals to what? So you can count and calculate the total first of all, and close the charge, and then after you find out the how it is that. So calculate the electric field produced by point charge using Gauss law. Okay. So now see, I given one example for you. So you can find out the flux phi is equals to what. So you can take the charge q2 plus q3 q4 plus q5 like that, and your addition of that. See, suppose here there is a q2 q3 q4 q2 q4 q5 is inside, and q1 q2 is that outside. But we are talking about the flux phi is equals to what, q enclosed upon epsilon 0. So q enclosed, it means what, the inside of the total charge q enclosed. So see, the q2 it is equals to q5 flux phi is equals to q2 plus q4 plus q5 upon epsilon 0. So this is our, you can solve it from these equations. So now the Gauss law, it is useful toward the much easier calculation of electric field when the system has some symmetry. So see, the Gauss law is useful towards a much easier calculations of electric field when system has some symmetry, and the surface that was enclosed for applications of Gauss law is called the Gaussian surface is that. And see, we are talking about already this all these topics. So Gaussian is true for the any closed surface, no matter what is the shape of size. And then after the term of Q on on the right side of equations include that sum of all and charge enclosed by the surface. The charge may be located anywhere inside the surface. Anywhere of the charge you can calculate it, and then you can solve it this one. So it is easy for you. So you can talk about it that this one it is our Gauss law. Okay, this one it is our Gauss law. So now see, afterwards we are talking about that in your book.